Hello everyone, today we are going through some important questions of arithmetic progression. First question, find the sum of first 8 multiples of 3. So here to find the sum of 8 multiples of 3, we have to write the numbers. Okay, that is 8 multiples of 3. So first number is 3, right? 3. Then next is 3 2s are 6. Then 3 3s are 9, 3 4s are 12, etc. See, what will be the 8th term? So here let's find an. We have a formula an, that is nth term is equal to a plus n minus 1 into d, right? So here what is a? A is the first term, that is 3, right? So 3 plus n. N is nothing but 8 because we have to find the 8th term, right? So a 8, that is equal to 3 plus 7 into d. D is the common difference, that is nothing but 3. Because here the numbers are the multiples of 3. Okay. 7 into d. D is 3. That is equal to 3 plus 21, that is 24. Therefore, 8th term is 24. Okay. Now we have a sequence. That is arithmetic progression. Now we have to find the sum of first 8 multiples of 3. Okay. So what is the formula? Sn is equal to n by 2 into 2a plus n minus 1 into d. Right? That is equal to, what is n? 8. Right? 8 by 2. Yes, 8 is equal to 8 by 2 into 2a, 2 into 3 plus 8 minus 1, 7 into 3. Okay? That is equal to 4 into 6 plus 21. That is equal to 27 into 4. 4 2s are 8, 10. 1 not 8. So, the sum of first 8 multiples of 3 is 108. Look at this question. Solve 1 plus 4 plus 7 plus 10 plus etc. plus x is equal to 287. Solve for this one means find the value of x. And here it is given that sum of these numbers is 287. Okay. And here we can see these numbers are in AP. Right. That is 1 plus 3, 4, 4 plus 3, 7, 7 plus 3, 10. Right. So it is in AP. Therefore, here we will apply the formula of a sum of first n terms. That is Sn. Sn is equal to n by 2 into 2a plus n minus 1 into d. Okay. Now, here sum is given, right? That is 287. That is equal to n. We don't know n, right? We don't know how many terms are here. So, n itself. n by 2. 2 into a. A is the first term, that is 1. 2 into 1 plus n minus 1 into d. D is nothing but common difference, that is 3. Right? That is equal to, take these 2 here. So it will be 574 is equal to n into 2 plus 3n minus 3. Right? That is equal to 2n plus, here 2 plus minus 3 minus 1. So n into 3n minus 1. Right? Next, 574 is equal to 3n square minus n. That implies 3n square minus n minus 574 is equal to 0. See, here we have got a quadratic equation. So here we need to find the value of n. How? By solving this quadratic equation. Okay. Now here we will apply quadratic formula for solving this quadratic equation, that is to find the values of n. Okay. So here a is coefficient of n square. Here n is the variable. Okay. So coefficient of n square is 3. Coefficient of n is minus 1. That is b is minus 1. A is 3 and c is minus 574. Okay. Now let's find n is equal to minus b that is minus of minus 1 plus 1. Okay. Plus or minus square root of b square is 1 square 1 minus 4 into a into c is minus 574. So minus minus become plus 574 divided by 2 into 3. That is equal to 1 plus or minus square root of 1 plus here 12 into 574. 574 into 12. 8, 14, 11, 1 4 are 4, 1 7 are 7, 1 5 are 5. 8, 8, 8, 6. Okay. So here we have got 6888. Plus 1, it will be 6889 divided by 6. Okay. Now, what is the square root of 6889? See, for that, first of all, we have to find a perfect square nearby this number. See, we know that if it is 6400, means 6400 is the square of 80. Right? 8 8s are 64, right? See, 80 square is 6400. Right? And it is greater than 6400. Okay, therefore its square root must be greater than 80. And which number? See, here the first digit is 9. Right? So 3 3s are 9. And what are the possibilities? 3 3, right? First digit will be 3. And or 3 or 7. 7 7s are 49. So here first of all let's take 83. Okay? 83 into 83. Okay? 3 3s are 9, 3 8s are 24, 8 3s are 24, 2, 8 8s are 64 to 66, 9, 8, 8, 6. See, we have got 6889. Therefore, square root of 6889 is 83. Okay. That is, it is equal to 1 plus or minus 83 divided by 6. That is equal to 1 plus 83 divided by 6 or 1 minus 83 divided by 6. That is n is equal to 1 plus 83, 84 by 6 or n is equal to minus 82 by 6. Here it is 6 1s are 6 4s are 24, right? So n is equal to 14 or n is equal to 2 3s are, sorry, 2 3s are, that is minus 41 by 3, right? Yes, minus 41 by 3. See, which is not possible, right? See, what is n? Nth term, right? So here the term n must be positive integer. That is a natural number, right? So here n is a natural number. So which is not possible. Okay, n is equal to minus 41 by 3 is not possible. And it is being negative and it's a fraction, right? So it is not possible. So here n is equal to 14. We have got n is equal to 14. That means 14th term. Okay, so 14th term is x. Then what is the value of x? So how to find? We have got, there are 14 terms. We have got the value of n. Now we have to find what is the nth term, that is 14th term. Okay, that is the x. So let's find, next we will find 14th term, that is a14. Okay, so here 14th term is x. a14 is equal to a plus n minus 14 minus 1 into d. Okay, a is 1 plus 13 into 3. That is 1 plus 39. That is 40. So here 14th term is 40. That is value of x is equal to 40. That's all. Find the sum of integers between 100 and 200 which are divisible by 9 and not divisible by 9. Okay, first of all, let's find the sum of integers between 100 and 200 which are divisible by 9. For that, we have to write the numbers. Okay, so that is NAP. So here, first number. What is the first number? See, numbers between 100 and 200. So here we have to find the first number greater than or equal to 100 which is divisible by 9. So how to find? See, 100 divided by 9 is 9 ones are 9, 1 is remainder, 9 ones are 9, 1 is the remainder. Right? See, here we have to add 8 to get 9. Right? Therefore, 100 plus 8, 108. So 108 is the 108 divided by 9 is 12. Right? So 108 is the first number that is greater than 100 which is divisible by 9. So what is the first number? 108. Then next is 108 plus 9, 117. Next is 126, etc. Now what is the last number? Last number means here numbers are between 100 and 200, right? So here we have to find a number less than or equal to 200 which is divisible by 9. Okay, less than 200 which is divisible by 9. 200 divided by 9, 9 2s are 18, 2 is remainder, 9 2s are 18 and 2 is the remainder. Right? So here we have to subtract. Okay, because less than 200, right? So 200 minus 2, that is equal to 198. So here 198 is the multiple of 9. Okay, so here 198 is the last number and less than 200 which is divisible by 9. Okay, so what is the last number? 198. Now here next we have to find the sum of these numbers. So to find the sum of numbers, here we don't know how many terms are here. Okay, so that is value of n. We have to find that. See, we know the last term, that is an. Okay, so here we will apply an formula, that is nth term. An is equal to a plus n minus 1 into d. An is 198 is equal to a is 108 plus n minus 1 into d is 9. That is 108 plus 9n minus 9. That is equal to 99 plus 9n. So here 9n is equal to 198 minus 99, that is equal to 99. So n is equal to 99 divided by 9 is equal to 11. Okay, so there are 11 terms. Means there are 11 numbers which are divisible by 9 and numbers between 100 and 200. Okay. So here next we have to find the sum. Sum is Sn, that is S11. Okay, Sn is equal to n by 2 into 2a plus n minus 1 into d. That is equal to, here n is 11, 11 by 2 into 2 into a, 2 into 108 plus n minus 1, that is 10 into d, d is 9. That is equal to 11 by 2 into here 216 plus 90. That is equal to 11 by 2 into 306, right? 306. That is equal to 11 into 2 is cancelled. Okay, 11 into 11 3s are 33, 11 5s are 55, 58, 58, then 5, 11 1s are 11, 11 5, 16. Okay, so it is the sum of first integers, sum of integers between 100 and 200 which are divisible by 9, that is 1000 and 1683. See, we are going to find the answer for B, that is sum of integers between 100 and 200 which are not divisible by 9. See how to find? here see it is nothing but sum of integers between 100 and 200 which are not divisible by 9 is equal to sum of the all integers between 100 and 200 minus sum of the integers between 100 and 200 which are divisible by 9, right? That is, here we have to find the sum of all integers between 100 and 200 which are not divisible by 9, right? So how to find this? So we have to find the sum of all integers between 100 and 200. Then minus sum of the integers between 100 and 200 which are divisible by 9. Okay. So here what we have to find? Sum of the all integers between 100 and 200. So for that, first of all, we will write the arithmetic progression. So what is the first number? Here integers between 100 and 200. Okay. So 100 and 200 not included. Okay. So here first number is 101. Okay. And second is 101. Then etc. What is the last number? Between 100 and 200. So last number is 99. Okay. See, on seeing this we can say how many terms are there, how many numbers are there. See, from 1 to 99, right? So there are 99 numbers. See, if you are confused, you can find the value of n using nth term formula. Okay. That is, so here, okay, now we will find the sum of these numbers. Okay. So Sn is equal to n by 2, 2a plus n minus 1 into d. That is equal to n is 99 divided by 2. Okay, there are 99 terms. Okay, divided by 2. 2 into a, that is 2 into 101 plus n minus 1 into d. N minus 1 is 98 into d. D is, see, otherwise we can write, see here we have first term and last term. Directly we can write a first term plus last term. Okay, in last class I have already mentioned. See, it is 2a plus n minus 1 into d is nothing but a plus n minus 1 into d. See, what is a plus n minus 1 into d? That is nth term, last term, right? So here a plus last term, right? So here directly we can write a plus, that is first term plus last term. Okay, that is 101 plus last term is 199. Okay, that is equal to 99 divided by 2, that is 200 plus 100, 300. That is 99 into 150. Right? 2 is cancelled. That is equal to 0, 5 nines are 45, 4, 5 nines are 45, 49, 99, 5, 18, 14. That is, what is the answer? 14,850. So it is the sum of all integers between 100 and 200. Okay. Now we need to find, okay, we have to find the sum of integers between 100 and 200 which are not divisible by 9, right? So that is equal to sum of integers between 100 and 200 which are not divisible by 9 is equal to sum of all integers between 100 and 200 minus sum of all integers, sum of the integers between 100 and 200 which are divisible by 9. Okay. That is equal to sum of sum of all integers between 100 and 200 is 14,850 minus sum of the integers between 100 and 200 which are divisible by 9 is, see, we have found already in A4 answer for A, right? That is 1683, right? That is 7 6 1 3 1. Okay, 13,167. The nth term of an AP, A, 3A, 5A, etc. is options NA, 2n minus 1 into A, 2n plus 1 into A, 2n. Very simple, right? So here, let's apply the formula, nth term formula to find the nth term of given AP. So here, AN is equal to A plus n minus 1 into D. So here, nth term, right? That we have to find AN. That is equal to A plus A. What is A? First term is A itself, right? Plus n. N is n. We have to find the nth term. So n, we don't know what is n. N minus 1 into D. D is it is given that it's an AP, right? Therefore, D is 3A minus A, that is 2A, right? So 2A is the common difference into 2A. That is equal to A plus 2A n minus 2A. That is equal to A minus 2A is minus A. So 2A n minus A, that is here A is common. Okay, A is common. So 2n minus 1 is the answer. A into 2n minus 1. B is the answer. Look at the last year question paper question. The sum of the third term and the seventh term of an AP is 6 and their product is 8. Find the sum of the first 16 terms of the AP. Okay, first of all, let's write what are given. Sum of the third term and the seventh term. If A is the first term and D is the common difference, then third term can be written as A plus 2D, right? That is third term is A plus 2D. And seventh term A7 can be written as A plus 6D, right? And it is given that sum of them, that is sum of the third term and seventh term, that is A3 plus A7, that is equal to 6. That implies A plus 2D plus A plus 6D is equal to 6. That implies 2A plus 8D is equal to 6. Here 2 cancelled, right? 2 is common. So it will be A plus 4D is equal to 3. That implies A is equal to 3 minus 4D. Okay. Now, what is given? Next. Their product is 8. And their product is 8. That is A3 into A7 is equal to 8. That implies A3 is A plus 2D into A plus 6D is equal to 8. Now here we will substitute what is value of A. Okay. That implies here A is 3 minus 4D plus 2D into 3 minus 4D plus 6D is equal to 8. That implies 3 minus 4D plus 2D minus 2D into 3 plus 2D. That is equal to 8. See, now it is of the form A plus B into A minus B. A plus B into A minus B. Right? That is nothing but A square minus B square. That implies 3 square 9 minus 4D square is equal to 8. That implies 4D square is equal to 9 minus 8, that is 1. That implies D square is equal to 1 by 4. That implies D is equal to square root of 1 by 4 plus or minus 1 by 2. Plus or minus 1 by 2. So here we have got the value of D. Next we need to find the value of A. So what is A? So substitute D is equal to plus or minus 1 by 2 in this any of this equation, right? Okay, here we can substitute. So here we have got two values for D, right? When D is equal to plus 1 by 2, what is the value of A? Here we have A plus 4D. A plus 4D is equal to 3, that implies A plus 4 into 1 by 2. 4 into 1 by 2 is equal to 3. That implies A plus 4 by 2 is 2. Okay, so A is equal to 3 minus 2. 3 minus 2, that is 1. So when D is equal to 1 by 2, A is equal to 1. Then next, when D is equal to minus 1 by 2, what is the value of A? Substitute here. A plus 4D is equal to 3 implies A plus 4 into minus 1 by 2 is equal to 3. That implies A minus 2. Okay, 4 divided by 2, 2 into minus 1, minus 2. Take this minus to right side, it will be 3 plus 2. So A is equal to 5. So when D is equal to 1 by 2, A is equal to 5. Now let's find the sum. Sum is 16, right? We have to find the sum of the first 16 terms, right? So yes, 16. So here we will get two sums. Why? We have two values for D. When D is equal to 1 by 2, what is the sum? N by 2, that is 16 by 2 into 2 into A. What is A? When D is equal to 1 by 2, A is 1. Don't be confused. When D is equal to 1 by 2, A is 1. So A, 2A, that is 2 into 1, 2 plus N minus 1, 16 minus 1, 15 into D, we have taken D is 1 by 2. Okay. That is equal to 8 into 2 plus 15 by 2. That is here 2 into 2, 4, 4 plus 15, 19. That is equal to, here see after taking LCM, 4 plus 15, 19 divided by 2, this 2 will be cancelled. So 4 into 19, 19 into 4. That is 4 9s are 36, 4 1s are 4, 76. Okay, so when D is equal to 1 by 2, sum is 76. Next we have to find when D is equal to minus 1 by 2, what is the sum? So yes, 16 when D is equal to minus 1 by 2. So here 16 by 2, N by 2, okay, 2A, 2 into A, what is A here? When D is equal to minus 1 by 2, A is 5. So 2 into 5, 10 plus N minus 1, 15 into D is minus 1 by 2. That is equal to 8 into 10 minus 15 divided by 2. That is equal to, similarly here we have to take the LCM, 20 minus 5, 15, 5. So 5 by 2, so 4 into 5, that is 20. So here the sum is 20. When D is equal to 1 by 2, sum is 76. When D is equal to minus 1 by 2, the sum is 20.